Graphing rational functions using FRATEY. FRATEY is a method that we use to make sure that we are capturing all key elements of rational functions. So, just a quick little reminder, a rational function is a fraction and it's going to look something like this: x plus 3 over x minus 2. Yes, it's going to get a little more complicated than that, but this is the basic kind of outline. We have a numerator, we have a denominator, and we use those to kind of identify different features. So, FRATEY, F is going to stand for factor. You need to factor everything in the numerator that you can, everything in the denominator that you can. And eventually we will get to the point where if something gets canceled out, we will end up with a whole. Not in our first lesson, but eventually we'll get there. Roots are going to be our x-intercepts. So what we're going to do is we're going to set our numerator equal to 0 and solve. That's going to create a coordinate point, x0, and graphs must pass through any x-intercepts and cannot cross the x-axis anywhere else. They're like a gateway. You have to go through the roots. You cannot cross anywhere else. A is going to stand for vertical asymptotes. And we get vertical asymptotes by setting our denominator equal to 0 and solving. And we write these as equations. X is equal to a number value. You can come close to a vertical asymptote, however, you cannot cross a vertical asymptote, just like we did with our rational parent functions. Now, something we're not going to talk about in our first lesson, but we're going to get to eventually, is twins, factors with multiplicities of 2. So if I were to have twins, and by that I mean maybe x plus 2 in the numerator over x plus 3 in the denominator, this set of twins up top, if it's in the numerator, it's going to be tangency at that point, meaning it's going to bounce off of it. If it's in the denominator, and they have to look exactly the same, we're talking identical twins. If it's in the denominator, they're going to come together at that asymptote. My two curves are going to come together. Now, in the behavior is going to function somewhat like our horizontal asymptotes. What is your graph doing as x approaches positive infinity and negative infinity? So that's going to be kind of dependent of your exponents. So if you have a bigger exponent on bottom, then the end behavior is y equals 0. So an example of that would be something like y equals x over x squared with some other factors. It's a bigger exponent on bottom. I'm doing very basics here. We will cover this more in our examples. If it is bigger on top, we're going to have a slant asymptote. Again, that's one of the last things we are going to cover. Say, for instance, it was x squared over x. And then if you happen to have the same exponents, we are going to divide the coefficients. So let's do something like x squared plus 2 over x squared minus 1. Same degree, same power of 2, I would just divide the coefficients. In this case, our horizontal asymptote would be at y equals 1. And you just take a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. Again, this is just a basic overview. We will get into this more as we start to do examples. For the first set of notes, you're really going to only be dealing with this eats DC portion. For y-intercepts, something you should be very familiar with, all we're going to do is plug in x equals 0 everywhere we have in the equation. It's going to create a coordinate point 0, y, and graphs must pass through any y-intercepts. They cannot cross the y-axis anywhere else. So we will go through each one of these steps every every time we start graphing rational functions. You factor. You set the numerator equal to 0. You set the denominator equal to 0. You check if you have any twins. Remember, twins have to be identical in either the numerator or identical in the denominator. Can't be mix and match. In behavior, you're looking at the highest exponents of your numerator and denominator. You have three options: bigger on bottom, bigger on top, or they're the same. And then your y-intercepts, you're plugging in 0 everywhere you see an x, and you get your y-intercept that way. One thing to note here, for x-intercepts and y-intercepts, they act as gateways. You cannot cross anywhere else but through an x-intercept or a y-intercept.